Hi everyone, and welcome back to educator.com. In this mini lesson we're going to do page 1 of the A+ Physics worksheet on wave behaviors. You can find a link to this worksheet down below the video. Let's dive right in. Number 1. While playing, two children create a standing wave in a rope as shown in the diagram below. A third child participates by jumping the rope. What is the wavelength of this standing wave? Well, it looks like that's showing half a wavelength, because if I were to continue that wave, we'd have to go back to there for a total of 8.6 meters. So the wavelength of that wave must be 8.6 meters. Correct answer, number 1. Number 2. The diagram below shows two pulses. Oops, I said that wrong. The correct answer, 8.6 meters. The choice is 4. The diagram below shows two pulses approaching each other in a uniform medium. 5 centimeters to the right and 10 centimeters moving to the left. Which diagram shows their superposition? Well, that just means we're going to add them up. The correct answer there must be 2. Number 3. Sound waves strike a glass and cause it to shatter. How sad. This phenomenon illustrates, well, that's resonance. Number 1. 4. A sound of constant frequency is produced by the siren on top of a firehouse. Compared to the frequency produced by the siren, the frequency observed by a firefighter approaching the firehouse, so if the firefighter is coming closer to it, the Doppler effect says they're going to observe a higher frequency. Correct answer there must be 2. Number 5. The superposition of two waves traveling in the same medium produces a standing wave pattern if the two waves have the same frequency, the same amplitude, and travel in the same direction, they're not going to interfere. If they have the same frequency, the same amplitude, and travel in opposite directions, you're going to get a standing wave. There's the right answer. Correct answer to number 5, 2. Number 6. The diagram below represents a standing wave. The number of nodes and antinodes shown in the diagram is, well, let's count the nodes. Nodes are the points that vibrate with minimum amplitude. So we have 1, 2, 3, 4, 5, 6 nodes. And then we have our antinodes. 1, 2, 3, 4, 5. And there's always one less antinode than node. So we have 6 nodes, 5 antinodes. Correct answer there must be 3. Number 7. A car's horn is producing a sound wave having a constant frequency of 350 hertz. If the car moves toward a stationary observer at constant speed, the frequency of the car's horn detected by this observer may be, well, the Doppler effect says if they're going toward each other, you're going to observe a higher frequency. The only answer here that's higher than 350 hertz is number 4, 380 hertz. All right, one more. Standing waves in water are produced most often by periodic water waves being absorbed at the boundary with the new medium. Well, that's not going to do it. Refracting at a boundary with the new medium. No. Diffracting around a barrier. Now that's bending around the barrier, but that's not going to give you standing waves. Reflecting from a barrier. Yes, that way you get the same amplitude, same frequency traveling in an opposite direction. So the correct answer to number 8 is 4. All right, hopefully this went well as we finished up the page on wave behaviors. If it didn't go so well, now would be a great time to go review it. And if it did go well, keep moving on to the higher level questions. Thanks everyone for your time, and make it a great day.